Okay, so sets it is. This is actually a pretty straightforward lesson. Y'all should get this pretty good. Let me know if you have any questions. Again, I am not looking at the video since I don't want to record y'all's videos on the screen. So, speak up or wave your hand at Bella. She can see and she'll let me know. Okay? So remember, a set is a group of numbers. When you write a set, you enclose them with brackets. And that's the little parentheses with a bump on the outsides. Here is a set of the ages of my kids. It's the number 2, 5, 8, 10, 11, 13, right? Here is a set of the counting numbers, 1, 2, 3, 4, ... Is she? I'll be darned. Okay, so that's a set of the ages of my kids as of Thanksgiving. Anyway, notice the ... The ... indicates that the set goes on forever. Do any of you guys know what the real word for that ... is?
Um,
The ... are those like
etc.
It's called an ellipsis.
Infinite?
Yeah, ... You got it. Okay, that means that it goes on forever, right? You indicate an empty set by having nothing in the brackets. Okay, so you see the brackets with nothing in the middle. That's an empty set. Okay, make sense? Questions?
Yeah.
Mark, you good?
Yeah, I'm good.
Okay, good. So the next thing we're going to talk about are finite sets. A set is finite if it has a finite number of elements. Go figure. The number of elements is finite if you could, in theory, with enough time, list them all. So an example of a finite set, the ages of all the peoples in the United States. Yep. The ages of all the people in the world. The bank account balances of all of the accounts all over the world. Or the number of kids in each of your families. And the number of presents your siblings got for Christmas. All of those are finite sets. Okay? Right. So you
it's
see
like
what I mean? They can be a lot of members. So like the bank account balances of all the accounts all over the world. There are, millions or billions of bank accounts. It would take a long time to write them all, but you could write them all. And you could at the end say, I wrote them all. That makes it a finite set. What? As opposed to a finite set, all of the elements of an infinite set cannot be listed. There will always be one more. That's why you need the ... or the ellipses. For example.
okay, so like
Yeah, go ahead.
a finite set is like a specific number, like it's limited kind of.
Yep.
But then the infinite sets, there's always more.
Exactly. That's where the ... comes into play. Bella, go get her some more. Yeah. That's where the ... comes into play. If you, so for example, you wouldn't be able to write out all of the odd numbers. Once you thought you were finished, you could always have another odd number. There would always be a bigger one. You can never write the biggest odd number. So even if you went forever, you would always be able to find another odd number by just going 2 higher than the last one. Right? Does that make sense?
Mm-hmm.
So here are some other ones. Infinite sets, all of the whole numbers. So if all the odd numbers are infinite, then all of the whole numbers are definitely infinite. All of the dates in the future, because there's an infinite number of potential future years. Right? And then the last one is all of the multiples of 27. So 27 times 2 is 54. 27 times 3 is 71, and so on and so on, or 81, so on and so on and so on. You can do 27 times any whole number, and you get another multiple of 27. If all of the whole numbers are infinite, then all of the multiples of 27 are just as infinite. Right? Does that make sense?
Yeah.
And it's funny because, you know, you'll start to think, actually, this is higher math than algebra, but there are different sizes of infinite sets too. You know, like all of the odd numbers are an infinite set, right? And all the whole numbers are an infinite set, but there are twice as many whole numbers as odd numbers. So that infinite set is twice as big, twice as infinity as the other one. You don't need to worry about that for now, but you get the idea. Any questions on finite or infinite sets?
Nope.
Mm-mm.
Pretty straightforward. So let's list the members in a set. Imagine the numbers 10, 11, 12, 12, 12, 13, 13, 13, 14, 15. How would you write that in set notation? You would say a set containing these numbers, and you list the name of the set first, or the title of the set. In this case, it's S. So S equals, and then you write the little brackets, and you write every element in there. Notice two things. You don't list any numbers twice. So even though 12 shows up in that original list of numbers 3 times, you only list it once in the set notation. Okay? And then one other thing is that it doesn't matter what order you put them in. So notice if we go 10, 14, 11, 12, 15. It doesn't matter what order they're in. You can put them in whatever order you want. It's nice if you put them in number order because that's kind of how people expect it, but it doesn't have to be that way. Okay?
Mhm.
So membership is indicated by this little round E thing. And it is pronounced is a member of. That is how you say the non-E, curvy E letter, is a member of. Non-membership is indicated by that same curvy E with a line through it. And that is pronounced is not a
Looks
member.
like
Okay? So you can see two examples there. 13 is a member of S. 16 is not a member of S. Okay?
mm,
Notice how it reads like English.
it looks
You
like
start with the member and then you end with the set. S is not a member of 13. Right, because 13 isn't a set, so it doesn't have members. Okay, so you write the number first or the members first and then the set afterwards. This makes sense? Any questions here? You got it, Rosie?
yeah.
Got it, Mark?
Yep.
Okay, good.
The sign looks like a euro sign.
It does kind of, yeah. Math had it first.
Hmm.
Euro didn't come invented until like 2000.
Oh, huh.
Okay, so now we're going to rearrange before graphing. So if you're going to graph an equation, remember how you have to make this little box of x's and y's. If I gave you the equation 4x plus 2y equals 8, you could graph it from there. But every time you picked an x, you would have to solve it for y. So in other words, if I said pick a -1, so then you'd have -4 plus 2y equals 8. So then you have to subtract or add 4 to both sides, subtract -4 from both sides, and you get 2y equals 12, and then you divide both sides by 2 and you get y equals 6. So you see in my table, -1 for x, y is 6. So that's a way to do it. It's actually a lot easier if you just solve for y first. Okay? So take that original equation when you have 2y equals 8 minus 4x. I'm sorry, subtract the 4x from both sides. So you get 2y equals 8 minus 4x. And then divide both sides by 2 to get y equals 4 minus 2x. And so then it's a lot easier to plug numbers in, and you don't have to rearrange the equation and solve for y each time. So in this case, you plug a -1 into that, you get -2 times -1 is +2. So 4 plus 2 is 6. See, it's a lot easier to find out what your different points are. So typically, if you're going to graph an equation, solve it for y equals first, and then worry about doing the graphs. There's nothing wrong with doing it the first way, but the second way is a whole heck of a lot easier. And you're less likely to make mistakes. So let's plug in a 0 then. So y equals 4 minus 2 times 0. 2 times 0 is 0, so y equals 4. And then a 1. Y equals 4 minus 2 times 1 is 2. So y equals 4 minus 2 is 2. And then let's graph those 3 points, -1, 6, 0, 4, and 1, 2, as you can see on the graph there. And draw a line between them. Remember, I do 3 points because that way you can make sure it's a way to double check your math for solving for y. If you ended up with a triangle worth of points, you know that it's not really a line. And you made a mistake somewhere. Okay? Does this make sense, Mark?
Yeah.
Make sense, Rosie?
Yeah.
Yep, okay. So pretty straightforward. I mean, we're not learning any huge parts with this. And that is the first lesson. So let me end the video and then I will start a new one. Just a second.